So today is the Thursday, the 30th of March, 2023, and the subject of today's Tech Hour is LaTeX and the arXiv access tree. And I think we all know what LaTeX is, and I'll explain what the access tree is later. And the arXiv is a massive preprint server with over 2 million submissions. So what I'm trying to do here is give a sort of broad overview of the architecture of what's going on, and also certain aspects of the problem that needs to be solved. And I'm doing that so that I can be part of a shared understanding, or at least if we can't have that, at least we know where we understand things differently. So we have a sort of common way of talking and understanding things. I think the World Wide Web Consortium has done very, very well in that, in terms of all its technical documentation and standards. The standards have to emerge from a shared understanding of the problem. And in a sense, I'm trying to do something similar to that, so that there is, across the people involved in the archives, very important accessibility project, more shared understanding. So I'm going to start with explaining what the access tree is. So we're going to imagine somebody who wants to understand Euclid's proof that there's an infinity of prime numbers, which has got a few formulas in it. It's mainly conceptual. Now, for a sighted user, you construct a visual object that the person could look at, either on a piece of paper or on a computer screen. For somebody who's not sighted, or who doesn't have a monitor connected to their computer, one has, for example, to use an audio rendition of the proof and the parts of the proof. And the sighted person can move their eyes around to go from one part of a proof to another, whereas the person who isn't sighted has to either get the screen reader to remind him or her as to what that formula is and what that equation is, or has to remember those things, which is a large cognitive burden. Either way, if you're sighted or not, if you're a sighted reader or an audio listener, there is a document structure which you can navigate with the keyboard if you're not sighted, and with your eyes if you are sighted. I think that's a really big difference between the two situations, is that the eyes do a lot of the navigation as long as everything fits on a single page. So the access tree is defined as the thing that allows the user, through keyboard interaction, to hear the document in a way that suits them, just as the navigation keys in a website allow you to read the website in a way that suits you. So the access tree is the model and the controller that allows the user to read or hear the document. It's the thing that is sitting behind the user experience and the human-computer interaction. If you know a bit about design patterns and that sort of thing, one of the old design patterns is a model, a view, and a controller. A model is a mental view of what the thing is like. A view displays the thing in some particular way or the other. Turning the page is changing the view. Searching for a particular term is changing the view. And then there's a controller which the user manipulates, it might be a mouse, in order to change the view. So typically you would click on a window to bring it up to the top. So you have a model, which is all the windows, the view, which is whatever the state is at present with some window at top having the focus, and the controller, which allows you to change the way in which things are presented and also allows you to change the model. So the access tree is really the audio access tree if the person is audio only, just as the for the sighted person, you have a visual access tree. In other words, every user has some sort of access tree with which their controller, which for somebody who's not sighted is largely just the keyboard, not the mouse for obvious reasons. And the view changes because an audio view isn't of any help to somebody who's blind. So that's where we want to get to. And it's the responsibility of users and user experience and human computer interaction specialists to define what that user experience should be. And from that, there will come some sort of specification, if you like, for the underlying document. The underlying document must have various features in order for it to have a suitable access tree. And from a software engineer's point of view, that is the specification that becomes important and interesting. So that's where we want to get to. When I mentioned Euclid's proof, it could be anything else. It could be the quadratic formula. The quadratic formula is a bit complicated, and you might want to navigate the mathematics through the keyboard, so you can read the numerator or the denominator as you wish, and you can see what's under the square root sign or not as you wish. Or one might want to look at Euclid's algorithm for computing the highest common factor, which is, what's the word? It's the first computer program that was proved to be correct. So it has a remarkable historical significance. Or it might be the proof of the irrationality of the square root of 2, where there the complication is understanding proof by contradiction. So there's a whole bunch of things that should be accessible to people who are not sighted. And I've chosen examples of that nature. So the key thing there is that the document, the system and the document together have to provide the resources from which the access tree can be built. And at some point, somebody somewhere will say, in order to construct an access tree, this is what I will need, because everything has to be defined according to standards, if you like. So that's where we want to get to, is the construction of an access tree. And I'm deliberately doing it this way because I'm focusing on what's necessary for accessibility for people who are not sighted. If we say we have to provide tagged PDF, then that's tying what they need to something that they don't need. And actually the same goes for accessible HTML. Probably the access tree will be presented using accessible HTML, but it doesn't have to be. As long as the interactions are supported, that's okay. And in some ways it's better to do things that way in an experimental point of view, because one can create samples much more easily if you don't have to go through all the processes of constructing HTML. So I'm now going to stop, and the next thing I'm going to talk about is going to be document formats. And I wonder if there are any questions or comments at this point. Nelson's got something.
Yes, I would just interject two little surprising bits of history. Euclid's algorithm for the greatest common denominator, or highest common factor, goes back to hundreds of years BC, and it's not clear that it was necessarily Euclid because so much was passed down verbally. In any event, it has the three components of any computer program. It has a test, it has iteration, and it has arithmetic. But the interesting thing, and it was, as Jonathan notes, it's been known for a long time to be correct. But what wasn't known for a very long time, more than 2,000 years, was what was the average time to completion and what was the worst case. And those were only discovered in the 80s and 90s of the last century. And very surprisingly, the worst case is when the two arguments of the function are Fibonacci numbers.
Oh, the Fibonacci numbers again.
Yes. So, yeah, but it's a rapidly convergent algorithm, but it's used in many computer textbooks as examples of simple programs, but it's subject to overflow if you're not careful, and the running time isn't at all obvious. It took a lot of analysis.
I'm sort of going off in a tangent here, but yeah. I'm beginning to think that there are a number of basic pieces of mathematics and computer science and physics and STEM, those sorts of, if you know what I mean, that are crying out to be done really well so that the standards can be set for accessible outputs. In other words, it's a bit like when you learn to play a musical instrument, which I've never done. You start by practicing scales, and learning to touch type, you start by practicing sort of semi-random typing. And just having some examples of how various things work in various formats could be quite helpful. And I'm thinking here of in the 1980s, I think it was, the Boston Computer Society did a survey of software for typesetting mathematics. And they had a sort of suite of examples. So I'm definitely in favor of having some sort of test suite for accessibility. If there's nobody else wants to chip in, you're welcome to if you want to. I'll move on to document formats. Okay, so I've identified 5 document formats that are relevant to us. The first is XML, which publishers really like because it's archival, and the software for manipulating XML is archival. And publishers, for very obvious reasons, want their stuff to last. The next is LaTeX as a document syntax, which is very, very widely used as the input syntax on the arXiv. The next is HTML, which can be thought of as a subset of XML, but I think it needs to be sort of considered something in its own right. HTML has things like JavaScript in it, which don't belong in HTML, which don't belong in XML. The next one is PDF, which is the electronic representation of the printed page. And the final one, which is one I've invented, is access tree. So I was talking about how the accessibility is going to have to produce an access tree for the user to interact with through the keyboard. So access tree as a sort of document format, I think, needs to be defined. Just as PDF is defined for rendering something for people to see, so access tree has to be defined as the underlying thing for somebody to interact with. Now, there are multiple processing routes. If you start with XML, then, and you want to get to PDF, and you've got a lot of mathematical content, then the usual route is XML to LaTeX to PDF. So the LaTeX file becomes a generated file, generated from the XML. And again, if you're starting from XML, you should be in a good position to create the access tree, particularly if you know what the access tree should look like before you specified what the XML should look like and before you wrote it. So the access tree should have figure descriptions. So there's a constraint on the XML. There will be lots of others. And then once you have the access tree, you can have audio rendering, or you can have some sort of rendering for the people with poor vision, so that the magnifying glass appears over the thing that is currently being read, or anything else, whatever is required. And then another route, which is being suggested by the LaTeX team, is LaTeX to tagged PDF, and then the tagged PDF is almost by definition a visible format, and because it's tagged, it's also an audio format, assuming you have the appropriate screen reader tools. It's worth mentioning here that if you can round trip XML and LaTeX, then you're in a very interesting situation indeed. And Kaveh might want to say something about that before I move on.
No pressure. So yes, so I think LaTeX, that's a good way to go. So if you start with, say, I want to make sure I don't ramble, but we can go from LaTeX to XML or XML to LaTeX. So that gives you a lot of flexibility. There's a lot of things and goes on in between, but basically, if we have XML, then we convert to a form of LaTeX, then use TeX to typeset it. We've modified the engine a little bit for the different reasons, but basically that's right. So LaTeX you can typeset and get a PDF. If the author's typeset in TeX, then you can take that TeX file, convert it to XML somehow using different methods, then convert it back to a LaTeX file, and then typeset that.
And the LaTeX file you typeset is not exactly the same as the author's LaTeX file.
It's not exactly the same as the author's LaTeX file. We pack a lot of things in there to sort of, to then embed into the PDF.
And that sort of makes it quite simple to use LaTeX notation mathematics in the XML.
In the first one or in the second one?
In the second. Means that you're not dealing with MathML when you're editing. Is that correct?
If you're at the authoring stage, of course, you've authored LaTeX, so you've got LaTeX. When you want to modify it, so there's a one-time conversion to say XML. If you want to modify that, supposing the author says this is wrong, or the copyer wants to change it, we have an editor which takes the XML on the fly, renders it as HTML, you modify it, and real time it saves it back to XML. So it's XML being modified on the fly. So yeah. Does that make sense? You're mute.
Sorry, I certainly find that helpful, and it gives us a taste of what can be done if resources available, because the arXiv doesn't. Nobody pays the old arXiv very much for every paper they host. They're working on pennies and dollars per paper, whereas publishers work on higher margins. But the idea that things can be done to improve the situation for documents that haven't yet been written, or if there are sufficient resources in that process. The thing I think about round-tripping XML and LaTeX is that the LaTeX you get is constrained. And I think part of the architectural solution for going forward is to have some sorts of constraints or nudges regarding the LaTeX that comes in. So as a typesetting for a journal, the paper is accepted on its mathematics or whatever its subject matter is. And then the poor typesetter has to do the best to make it fit. With the arXiv, some sort of feedback on submission saying, there's stuff here that's going to cause accessibility problems. Can you help us? Or can you do something else? Might be a way to go that's part of the solution.
Yeah, so if I can jump in there, I've been thinking, if we're talking about the arXiv, I feel there are two problems here. One is the legacy 2 million documents that's been there for 30 years or whatever over the last 30 years. And basically no one's been policing it. You've got simple tech, you've got complicated tech, you've got LaTeX that can't be read. That's one problem there is, to convert that into some sort of accessible form. Then the other problem is going forward. Going forward, we have the benefit to and as you say, Jonathan, to handhold the author to say, look, can you please use this or don't use that? It would be prefer if you do that. You can't constrain them fully, but for example, you could say we'll publish quicker if you do this. Then it's a simpler solution going forward. So I feel you've got those two problems to solve. But you're right. I think some sort of hand holding where the author says the author presses the button and some kind of some sort of device or a validation program says, yeah, that's good enough for us, we'll accept it. That's what I feel.
I have a question for David and Christopher. Publishers, the big ones at least, Springer and Elsevier and so on, are very keen on XML. Does XML enter into what the arXiv does at all? Because I don't see evidence of authors producing stuff in XML. I mean, Arnold Robbins and I wrote our book, Classic Shell Scripting, in 2005 in XML. But what did the publisher do for production? They put it into a word processor and then proceeded to mangle it.
Yeah, we're not working with XML at this point. We are, but well, Chris and his team are working on converting documents to HTML.
Right.
Maybe he could.
You keep metadata, for example, in XML format?
Not really. No, it's in a database and it's in some old metadata form. We are working to overhaul our metadata format.
Okay. One of the reasons I bring this up is I had occasion earlier this week to revisit the University of Trier computer science database in Germany, which is now was started at the university, but it's now maintained by a consortium, Schloss Stagstuhl, and so on. And I downloaded the entire database, which is all in XML format, and it's reasonably clean. It has some irregularities in the spacing, which made conversion back to BibTeX form a little difficult. But in reading their website, they commented that they really liked BibTeX form, and so, but they found it difficult to parse, and so they essentially developed an XML schema that was based on BibTeX markup and used that to represent, so the usual author, title, volume number, pages, and so on. And that seems to be fine. What I noticed was absent was the really critical thing for BibTeX, and that's the markup of proper nouns and titles to protect them from downcasing in various styles. And that's, since they have millions and millions of entries, this is not a trivial problem to solve. And I converted many hundreds this week to BibTeX form, and it took quite a lot of patching to clean them up to make them usable.
Just on that point, Nelson, you were saying, you created XML and submitted it. every publisher now, every single publisher will send whatever you send to them, they'll send it to a, let's not say every single, but almost everyone. They send it to a vendor. And these are vendors with, you know, we're a small vendor, but the vendors with literally thousands of employees. The last vendor I talked to, I said, you must be quite big now. You must have, what, 5,000, 6,000 people now. He said, no, we're not actually 17,000 people now. This is one vendor. They're not just doing STM, they're doing other things. But typically, literally thousands of people cleaning up Word, LaTeX, etc. Every single one of them will ask for JAT XML, right, from the vendor. And then from there, they produce different things. If you were to, I don't know of a publisher who will say, if you go to publisher, say, I've written my paper and here it is, it's in JATS XML. As far as I'm concerned, I don't think they'll know what to do with it because the system isn't there for that. They want a Word or LaTeX. They want actually a PDF file. The PDF file goes to peer review. The peer reviewers take the PDF file and say, yeah, page 5, line 66. And if there's no line numbers, there's an automatic numbering, as you know. Then once all that's been done, everything that the author has given is dumped to India or Philippines or somewhere. And they've got a week or two to come back with all what's called deliverables. So the system, you know, it's not a flexible system from what I can see. I mean, we'd love it if you give us XML. Great, you know. Maybe it's the way we work, but that'll go straight into our system. If it's copy editing, we can copy it in the HTML, and the XML is updated automatically. We press the button that saves us tagging, but for some reason. Yeah.
I'd like to come in now and continue from my prepared remarks. I'm really grateful for what's come up. I hadn't thought of the importance of data cleanup, and at the arXiv for accessibility forum, there's some talk about using machine learning, artificial intelligence to help with the problem, and any automated means of identifying and fixing problems that need cleanup would be very helpful. And the other thing is, I mentioned XML. XML can be all sorts of things. I think JATS XML deserves an entry in its own right because it's so widespread in publishing. So there's XML and there's JATS XML. So I'm going to sort of focus again on the problem of producing accessible outputs for the arXiv. And because of the size of the problem, because of the 2 million articles, I think it's worthwhile spending some time first to understand the problem from the point of view of the source end, and also hope that the users and the human-computer interaction and user experience people can give us some help regarding what the access tree should look like, because then that tells us what the outputs are that we need to be getting. Now, in terms of understanding the problem and in terms of solving the problem, there's something interesting happens. Converting the legacy documents, the ones that have already been submitted, is both easier to understand and harder to solve. The reason why it's easier to understand is because the starting point is a known fixed point. It's everything that's been done already in the past. Whereas going forward, the starting point is something that can be changed. Because we can change the starting point, the problem is harder to understand because we have to decide how we should change the starting point. And the problem is easier to solve because we are allowed to change the starting point. So I'm saying that to understand the situation, we should start by looking at the legacy stuff. And when we look at the legacy stuff, we can find out what the problems are for conversion, and that will tell us the forces that we need to take into account and to apply in order to improve the situation going forward. So I've got a strong interest in understanding the legacy stuff because it's fixed. It's easier to understand and it's easier to know what the problems are. So if we can clearly define the problems in the past, we can set up methods to ameliorate or reduce them in the future. Now, I think there are some special areas. Again, the conversation we had earlier brought references in BibTeX to the fore, which is a special part of the document. There's also what's traditionally known as penalty copy, which is tables and mathematics. And that's where the difficulty lies, I think, and that's where the value lies. Now, I'm mathematically a combinatorist, and because of that, I'm very interested in the special case of upper triangular matrices of positive whole numbers. I study these things a lot, and they correspond to a combinatorial change of basis. And a lot of problems come down to finding the right basis, just as in mechanics. Solving a problem in mechanics is often a problem of finding the correct coordinate system. If you describe the thing in the correct coordinate system, then the equations become easy to write down. So an example is the matrix whose first column is 1 and then everything else is 0. And then the next column is 1, 1, and then everything else is 0. And then the next column is 1, 2, 1, and then everything else is 0. And then the next column is 1, 3, 3, 1, and then everything else is 0. And then it's 1, 4, 6, 4, 1, and then everything else is 0. And this is just Pascal's triangle turned on its side. So Pascal's triangle is an example of an upper triangular matrix. And as I said, these things are very important in, for example, the online encyclopedia of integer sequences. And if you think about how you're going to present such a thing to somebody who is not sighted, you'll obviously want quite interesting abilities to navigate the thing so that the person can see that the thing is constructed according to various rules, and by understanding the rules, see that various properties hold. For example, the sum of the columns of this triangle are always the power of 2. And that's a consequence of the rules used for its construction. So for a sighted reader, all that's required is to see the triangle and to have words that say, move your eyes this way, move your eyes that way. Notice that, and possibly some extracts of the triangle so that you can see how this particular number is produced. So I see that as just one of the number of special cases that are important enough to be worth solving, and not that special. They're sufficiently unspecial, they're sufficiently general, that one would like to be able to make them accessible from the point of view not of the technical standards, but from the point of view of the user experience. So I'm going to now, if I can find my piece of paper, my piece of paper has disappeared. Here it is, it's on another piece of paper. So I'm now going to sort of say a few words about technical architectures. So one technical architecture is to author in XML. And that's what the pretext people do, the people in the American Institute of Mathematics. They've come along here a few times, David Farmer and Rob Beezer. And they author in XML using a variant of DocBook, and then they produce PDF and pretty good accessible HTML from what I can tell. I'm not an expert. And they have a program to produce accessible mathematics at college level to cover a wide range of college mathematics. And whilst that doesn't give any direct help to conversion of the stuff on the archive, I think it's a real leg up in terms of defining what the access tree should be. There's always the problem with this. So if you want to test the stuff with real users, and I think they've probably got some very good things for testing. If you want to test some mathematics with real users, I would use their system to create the accessible HTML rather than a LaTeX system, because it seems to give more power, more control, and it seems to be better tooled. So that's a question of creating sample access trees or documents so that we can firm up what we need to produce as outputs. Now, having done that, there are two main architectures if you want to tackle the legacy problem on the archive for the documents that are authored in LaTeX. You can either use the LaTeX source or you can use the LaTeX output. And I'm not aware of any work being done that combines the two, and that would be an interesting area. So the systems that use the LaTeX source are LaTeX ML, and there's a system also called PlasTeX, whose goal really is to produce validated XML, to define a subset of LaTeX. So one of the tools, PlasTeX is a tool that converts LaTeX because it uses a subset of LaTeX. So defining subsets of LaTeX are a question of using the LaTeX source. So LaTeX ML has already converted a large part of the archive, and in conversation with Carve this week, we realized that it'd be really good to know how good are those outputs in terms of accessibility, because we don't have solid evidence. I'm not aware of solid evidence either way that LaTeX ML has solved or has not solved the accessibility problem that we're discussing. And I'm really interested in seeing results on that. So that's using the LaTeX source. The other side is to use the LaTeX output, and there identify three tools. The first is Tech for HT, which Carve, I think, knows a lot about. The second is LWarp, which is Brian Dunn's reworking of LaTeX for HT. And the final one is UnLaTeX, which is something I've currently started and is very much still a mewing, crying baby. Also in this camp, I think must go, now the LaTeX project to produce tagged PDF sort of uses both camps. It uses the LaTeX source and it tries to understand the LaTeX source. And it uses and modifies the output of LaTeX by putting tags in. So that's quite interesting. I'll make a personal remark here, which is if the goal is to produce an access tree, then I say produce the access tree that you want to have without constraining it by the rule that you must do it using LaTeX and embed it in a PDF. I think the accessibility is large enough a problem that we shouldn't have to be constrained in that way on the tools that we use. And there are not many people can reliably write tech macros. I mean, I used to be one of them. I don't suppose I am now anymore. So I've sort of got a recommendation here, which is that the archive provide, or somebody else, if not the archive, provide a representative sample of about 50 documents for a pilot survey for conversion and testing. So we have 50 documents. I think that's large enough to be interesting and small enough to be practical. And for each document, we try to do the best we can with it. And the main purpose of the pilot survey is to discover what the correct questions to ask are. What are the correct questions to ask? That's why you do a pilot survey, is to find out what the right questions to ask are and how to ask them. So if we can identify things that are conducive to success and things that are conducive to failure, then we've got questions that we can ask of larger bodies of material. So I think I'm going to stop at that point. Oh no, there's one more thing that's important, which is the author experience. So the cited author checks by seeing. That's what I do. I print it out on my laser printer. Not very useful if you're blind, but I print it out on my laser printer and I check that everything reads correctly. And it's well known that it's only after something that's typeset that you notice the typos. You don't notice the typos in the source file. The audio author, has to check by hearing. And I've been struck by Jonathan Godfrey saying that his use of the R tools, R Markdown in particular, means that he can proofread using the accessible outputs. And then my gloss on that is, once he's done that, if the PDF is not correct, then it's a fault in the system. It's not his fault for not proofreading the PDF. It should be possible to proofread the document using the audio outputs. Now, the graphics card and the windowing system are sophisticated software that supports checking by seeing. We don't have similar sophisticated software for checking by hearing, so far as I know. And an example is the WYSIWYG system, or even an instant preview system, gives you feedback, quick feedback regarding non-change and change in the document. We think that WYSIWYG allows you to see the changes quickly. Well, it does, but that's only because it also allows you to identify very quickly the regions that haven't changed because they haven't moved. Now, if you're an audio user, you can't scan the whole page at once. So authoring tools are quite an important thing in this whole area. So I'm gonna stop and ask for contributions, questions, comments, anything else.
I got one. Can you mention the tool again that you were suggesting for creating access trees for HTML? I think it was for processing HTML.
Okay, the access tree is unfortunately something that has no real existence.
Mm-hmm. You mentioned a tool for, I think, creating HTML or accessible HTML. I wanted to make sure I got the name.
Oh, there's Pretext, which is out of the Puget Sound people. That's I'll put it in here. They're creating books that math books that contain accessible content, and I think they even generate Braille if you want it. So they're going down the old XML route of having a schema and writing tools to transform everything, and they use XSLT a lot. So I had that in mind when I was saying, if you want to generate some good samples to give to people who are blind, so that they can see how they get on with them, I would probably use Pretext to do that. Yeah, Carve's given us the real link. Thank you, Carve. Pretext.org. Is that what you're looking for, Christopher?
I think so. I realized you mentioned one and I didn't get the name, so I wanted to.
There's also Plastech.
Plastech.
Now, Plastech is a tool for both validating LaTeX and also for producing a document tree. So Plastech generates a document, a DOM, its own DOM from LaTeX. Can I come back with a question, which is, would it be helpful to sort of produce an annotated bibliography or whatever it is of resources? Is that something that would help you in your work, Christopher? Is that something?
I think so. I have an opportunity to work with groups of students, and I carve out good tasks that are both helpful for their development as people going into industry or going into academia and as researchers, but also help out arXiv. So I'm always looking for interesting projects that we can turn into student projects. So generating this kind of accessible, translating a paper into another accessible format sounds like an interesting project for some of the students that are interested in accessible UIs, for instance. So I wanted to get the names so I could look into them and think about them as potential student projects, or at least being involved in a student project. As far as testing the HTML output, that's our first round of business. Once we're working on an interface to get feedback from readers, both visual sighted readers and people using screen readers, to tell us how they find the HTML conversions of articles. So I have a group of students working on that interface right now.
Yeah. I just did a scan of the contents of the TechLive 2023 tree, and I don't find anything with Plastech in its name. Is this sort of outside the development or somewhere in the CTAN tree, perhaps?
The point is that CTAN and TechLive doesn't support Python. And Plastech is a Python tool. That's sort of the long and short of it.
So what's the very brief? What's the elevator pitch of what Plastech does?
The elevator. It allows you to author in LaTeX and typeset the LaTeX, and also from the LaTeX get a document tree that you can render to XML or HTML as you wish. So Plastech isn't a complete solution, although it does have some turnkey capabilities. It's something that's designed to be extensible. And it achieves that extensibility by constraining the LaTeX that is permitted.
Okay.
I just did another quick scan and found that Plastech is not in the CentOS Red Hat package system, but it is in the Ubuntu 20 package system.
Okay.
I will probably install it and play with it.
The other way to do it's a Python module, it's a Python package, and so you can install it from the Python package index. And because it's a pure Python package, it doesn't have any object code or anything in it. It can just be installed through pip install, which is the Python installer. So it's just like a Perl module. You know, an ordinary Perl module, you don't have to go through the packaging system of your operating system to get it in. You can just download it, or Emacs Lisp macros. They just come from the Emacs Lisp repository. So yes, so that's where Plastech is.
Thank you.
It's nearly past. I'm going to do the old-fashioned thing. What I used to do is anybody that wants to go can leave at past, and we'll say goodbye to them. And then those that want to stay are very welcome to stay.
Today, I actually have a visitor coming for lunch, and so I probably should drop out at this point. Normally, I would hang on, but
Well, it's nice to see you, and I hope you have an interesting visitor. You can tell us all about it next time if you want to.
Bye, Nils.
So we're still recording, and we can open it up quite a bit if people want to. I presented with the view to trying to get things better prepared in the circle around me, because that's the only one I've got any influence on, for the accessibility forum next month. I'm a bit disappointed that the tech community as a whole hasn't seemed to have had much interest, because I very much believe that the accessibility forum next month will be the most important event for the future of tech for several years, since several years ago. I can't think of any comparable event in the last 5 or 10 years in terms of the future of tech.
Ooh.
Because it's dealing with a large major problem that is a real world problem. The closest that's come to this is the various attempts of the LaTeX 3 team to make LaTeX a more congenial and useful environment for doing various things.
What do you think is the reason for the lack of interest?
It might be age, that the people just want to keep going in the same way as they've gone before. I think that whatever the reason is, it's the same reason that UK Tug was presented little resistance to being dissolved, and it's the same reason that there were no contested seats at the elections for the Tug board and Tug president. And the Tug vote, the journal, is nowhere close, has made, in the last 25 years, it's made no progress towards accessibility. The journal of the Tech Users Group is just as accessible now as it was 25 years ago, which is its PDF. So all of those things sort of tie together. And
I think, ironically, the tech community is very conservative. That's the thing. It's a group. I think still Tugboat doesn't have a DOI, I believe, right? So you can't. It didn't have last time. I looked a few years ago, but I mean, there are extremely brainy people in the Tug community, but I feel it's quite insular. Yeah. Got to be careful what I say. This is being recorded.
Yeah. It is being recorded.
There was a couple of things I was thinking about. Yeah, so one, Chris said you're looking to look at how accessible it is now. Any idea? I mean, do we have any idea of the HTML is now available on R5? how useful it is, how accessible that is, I have no idea. Or not.
No, in general, from the user feedback, we understand that HTML is a good target.
Sure.
Um,
Yeah, I
but
agree.
yeah, it's important that we actually put this HTML in front of people and say, how does this work with a screen reader? How does this, is this badly organized? What's the variability? Does it come out good in general, or is it just a few papers that are actually good and there's so many anti-patterns that aren't solved by converting from LaTeX to HTML that the end product might be unreadable? So we need to test that. That's definitely on the list.
Okay, so that's one of the works in progress, is, so to speak, real testing of R5 outputs.
Yes, that's.
I think that Jonathan's suggestion of having, say, 50 random papers and just randomly testing this and saying, giving scores, that would be an interesting thing.
Jonathan, do you want random papers? It didn't sound like it, but
I'm not asking for random papers. I'm asking for well, the pollsters who try to predict the way the election is going to go. They try to produce something that's sort of demographically proper.
So 50% CS papers. And
it's really difficult nowadays, but simply to have a list of 50 random papers is better than nothing. And at least if it's random, then there's no sort of hint of bias. Maybe 50 random papers and then 50 special papers, that we need something in this area, we need something in this area. This is an important paper that a lot of sort of poster child papers, if you like. But a small sample that people can work together on and compare results, I think, is really helpful. And it's sort of what happens in the data science community is there's something called Kaggle, where you're given a machine learning problem and different people, and you compete to see who can do the best solution with given resources on that machine learning problem. And it's quite good for both recognizing excellence and improving standards, and I think improving communication, because if you and I have both done the same Kaggle problem, then we can talk to each other about what went right and what went wrong. Whereas if you and I try and create accessible HTML from different papers, we don't have that shared experience. So I think just saying, here are 50 papers, we're going to make a we're going to do our best to make accessible versions of them, would be a great community building and learning experience. And for somebody like myself, who's just sort of coming in a bit cold and would like to get going, it means I can say, oh, well, I see what these people have already done. I'll try my tools on it and see if I can do better. And maybe I'll learn that I'm not as smart as I thought I was, and the problem's harder. and that would be a result.
And in some ways, I'd like to have a paper that really tries to hit all the different kinds of elements that can exist in a paper. Because it takes a lot of papers before you hit like the full range of what is possible to include in a paper. Right. So in some ways, I think we could design a paper that was a really good test case that included, it has tables, it has equations, it has maybe a table of contents, it has footnotes, it has references, of course, various levels of subheadings. It has multiple authors that need to be mapped to multiple institutions. What else could it have? Appendices, has code, you know, it has images and charts, and all of these things together in one paper will let us really explore which things work well and which things don't. Getting an exhaustive list of all the elements that a paper could potentially include in designing a paper around that, I think, could be really helpful.
I think that's a different sort of thing. It's a sort of test suite. There are tools now that check that every line of code is executed by your test suite. Famously, Don Knuth wrote a compiler for some computer in the 50s or something, maybe the 60s, and there was one line of code that however hard he tried, he couldn't get the test suite to exercise it. And then he did some work and he found that that line of code could never be executed. So he deleted it. But what you're saying is, let's have, or in tech it's called the torture test, which is that if there's a fault in the document conversion system, this paper is so horrible it's likely to find it. And there's a real role for that sort of paper, that sort of test. But there's also a role for well, here's something that is fairly random, but it's pretty easy to go through a tech paper and make a list of all the control sequences in it. And you might get some failures because it's using verbatim, and that doesn't matter, because papers that use verbatim are going to cause difficulties anyway. So if you get wrong answers, that's all right. But make simply a list of all the control sequences in the paper might be a good indicator as to whether or not it converts correctly or not. If there's a lot of unknown control sequences, you might think, well, it won't work properly. So it's those sorts of things, because at some point we want to be able to say, well, here's 100,000 articles. Before we put it through the conversion system, how many do we think are going to run to completion? And how many do we think are going to give decent outputs? We ought to know that before we put 100,000 articles through. I mean, if you've already put 500,000 through, we should know what happens for the next 100,000. Just as this is the classical thing about statistics. When statistics of murder, I'm afraid, when it was found that there was a tremendous uniformity of the numbers of murders committed in a particular town, there was this question as to, well, where's human free will? You know, the laws say that there have to be 5 murders next year, which is very regrettable. But what does that mean for human free will? But it's just statistics. It's you know, every murder prevented is a murder prevented. But having a useful set of statistics on the arXiv papers will be really helpful.
I was trying to find that for R5, but so far I don't see it.
What statistics on how it works? Yeah. I mean, something that's probably quite easy to do. It's got nothing to do with the formal accessibility, but it's got a lot to do with the readability. Is to what degree do we have superscripts on superscripts and superscripts on subscripts on superscripts and that sort of stuff? You know, these x sub I squared, where it's the I that is squared, that sort of stuff. So the reading complexity, if we could measure the reading complexity of papers, that would be quite interesting, because the papers that have low reading complexity in terms of the mathematics should also have high conversion successes for accessibility, I would expect. It would be nice to know whether or not there was some correlation there, because then that will allow you to pick out papers that are saying, well, these ones should work. And if they don't, I'd like to know why.
I think there's a GitHub issue on the LaTeX ML GitHub that talks about what are the things that make paper conversions fail, and they've identified the like top failing packages and that sort of thing. I can't find it right away, but I believe it exists. I think it's a public document.
Well, that's great. I sort of think we need a bit of light organization here. I don't think the tech hour is the right place to do it because lots of people won't come or can't come. But some sort of public place where we share, a forum, if you like, where we share information. So that would be a natural outgrowth of the arXiv accessibility forum, is that there should be some online fora, which could be just a mailing list or GitHub project that's mainly used for issues, which is the go-to place for discussing these things. A lot of people use Discourse now, and that's supposed to be pretty good.
Yeah, I believe Shamsi is planning something that will go on beyond the forum for people to share and discuss things about these issues. So,
oh, that would be great. That would be a really positive outcome.
And I guess the other thing I wanted to mention is that I think the forum will have individuals from the LaTeX group, LaTeX ML, and Overleaf as part of the forum.
So we're getting the right people together, which is great.
So,
just on looking at what right now the R5, I just had a few, I had a quick look at a few papers. It is astonishing how how good the rendition is, knowing that there are millions of or hundreds of thousands of papers, or over 1 million. It's done a good job but that's for me a sighted reader. I have no idea what's behind the scene. It looks beautiful. I can read it. I had a quick look at the HTML. It is pretty complex. It's got lots of things. It's quite verbose. So that's the question. An accessibility tool, will it pick out the right bits out of there? And if it does, how useful is that? So that's what's missing for me at the moment. But you've got to give credit to Dayon for just quietly converting whatever 70% of 2 million papers. So
well, I think he's getting a 70% hit rate. Is that right, Chris? It's something like, it's pretty high.
It's completes a conversion is the criteria. So it doesn't crash. That's one criteria. That's a good one to start with. But there's more that needs to be done beyond that. And I agree that we need to get these in front of a screen reader sooner rather than later.
Yeah. That's the first thing to do, I think. Just see how, where is it lacking?
I wish the number was much higher, but as somebody who's developing what might be a rival, I'm sort of at the same time. You know how it is. I'm pleased that there's a 30%, which I can have a go at and see how they work, see how it works with my stuff. I know that my stuff will always work, but it may not produce decent outputs. But you can always look at the boxes and do something with what's in them. The process is sure to complete, I think. But
and it may be you've got more than one method. So it may be there is 3 or 4 methods, and for looking at legacy, some of them work through your technique. Some of them work through the complex ones will come through. For example, if one's got very, very complex macros, the LaTeX ML will fall over. But the native tech, by definition, will read those. So they need to automatically go through these different routes and find whichever one goes through. So it's not an easy problem, because you've got going back, tech, it was designed to be flexible. It's written by the world's cleverest guy, arguably, and it was written before the internet. It was written before any kind of electronics, So, and it's designed only to produce a nice page. It was written before PDF, PostScript, etc., just to have a nice print. So it is a challenge to take that now, that with full flexibility, and it's just the most complex programming language. Again, arguably. So now to make that accessible, it's a challenge, but worth pursuing for sure.
I'm thinking that tables are a special case, and a special tool for tables, both for legacy and for going forward, is probably wise. That creating accessible tables is sort of problematic, and a table wizard where people could author tables and know that the outputs would be converted to something that's accessible would be a great tool for authors. Mm-hmm. And it's perhaps the best way for dealing with complex tables is that they have to use a wizard.
So this is solution for going forward, right?
Well, yeah, for going forward. Yeah, the reason I said that was because a typer, Atipia, whoever they are, Carve knows the company. They say when you submit to this journal, you need to submit the tables separately so that it can be processed separately. And if they're doing that, it sounds like it's a good idea, because the outputs that they're producing for the proceedings of the National Academy of Sciences look quite nice. And having a controlled environment for the writing of tables seems to me a good idea from the point of view of an access tree.
Sorry, ATIPy, are you talking about the typography? There's ATIPy, which is a typography conference, but that's not...
No, I'm talking about a typesetting provider. They're based in Stanford. I forgot.
Atipon?
Sorry? Atipon?
Atipon. It produced Atipon. They're not a typesetting provider. They're a platform. They're a hosting platform.
Right. Okay. So whoever they're using for typesetting wants the tables separately. I think there's a lot to be said for taking the mathematics out of the document and correctly identifying the mathematics is a quarter of the problem of accessibility. That's a bold statement, but if you can correctly identify the mathematics, then you've got the problem of converting the mathematics. That's one problem, and it's a very restricted domain. And then you've got the problem of converting the words, and that's again a restricted domain because there's no math in it. So a tool for just doing the mathematics would be quite interesting. There's something called MathPix. I put it into the chat, which does very good OCR of mathematical content, and you can use it on typeset content. And one way to get hold of your mathematics as LaTeX, MathPix will produce LaTeX for you. Is you can typeset your mathematical formulas one per page and ask MathPix to convert them, and it will produce LaTeX from them. And I was very impressed by what it did, and that was one of my motivations for run LaTeX, because I wouldn't even have to use OCR. I'm just using the raw material from which the PDF is constructed. So dealing with the mathematics, it may be that one system works well for the mathematics and some system works well for the bibliographic stuff and some works for the cross-references and links. There's all these different parts of the thing. And if we can sort of break the problem into parts, then it becomes, I hope, simpler and more manageable. At the same time, we have to keep coming back to LaTeX ML and the arXiv, because it's a big achievement, and we want to know how good is it, what they've done. Is some of it already ready to be presented as accessible outputs? That's a good question.
Mhm.
Of the 70%, is there even 10%? So 10% would already be enough to be interesting. If there's 10% of it which says, well, this stuff all looks pretty accessible and we'd like you to look at it, and we're really grateful to the arXiv people and the MathML people for providing it, that would be a great step forward. 5% done would be a really big step forward. And we've got it already. And the tools used to determine which of those conversions belong to that 5% are automated quality tools. And that's very important too. So simply being able to identify 5% of the R5 conversions that are successful in terms of the end user would be a really big plus. I'm not talking down and saying R5 can only do 5%. I don't know how much it can do. I hope it can do a lot more than that. But even if it did only 5%, that would be a really big achievement.
Yeah, because that might be 5% that the other tools don't do. That's the thing, you know.
Yeah,
that's a lot of papers, 50,000.
It's a lot of papers, and the biggest secret is knowing that it can be done. So I'd be very interested in that.
I will share our results once we have them and I have permission to do so.
Okay, so you're working on that. Ooh, I'm very much looking forward to seeing what those results are. We don't have to stay for 2 hours. We can wind up a bit earlier. I'm happier to stay, particularly as I'm feeling in a good mood.
David posted a link, the one I was looking for before, reporting on the conversion results for R5, I think.
Yeah, I got that.
Yeah.
Yeah, I mean, we did have some discussion internally with the R5 folks, and I think there's a difference between like successfully converting and accessible. So while successfully converting is good, I think we need this tool that's going, I guess it's a tool or something that assesses the accessibility and you know, gives us a good idea, you know, what the issues are aside from these other stats. But I think actually having users trying it out and providing feedback is also going to be helpful. I mean, that's part of the plan with arXiv and the work that Chris and his group is doing in terms of getting the HTML in front of people, having them look at it, having them provide feedback. I think that'll be good. So.
I think it's the creation of a community that is one of the most important things. And in some sense, it's the easiest thing. It's just a question of being kind, being nice, being interested, sharing all these.
Yeah.
But it's typically quite difficult.
Yes. I think from my standpoint, I mean, Shamsi has done an amazing amount of work to push forward, you know, accessibility at arXiv and develop this forum. I mean, and I think there are maybe 700 people that have signed up for it so far. So I hope this is just the start, and we keep this momentum going into the future. And
if you've got 700 people signed up, then that's a major mailing list there, and it would support a monthly newsletter. I mean, the tech users group, admittedly people have to pay to join, has about 800, 900 members, I guess. So, so that's a pretty weighty thing, and some sort of forum, some sort of newsletter, and some sort of loose governance.
It's a very good point. Obviously, you can ask them. Well, I'm sure Shamsi is ahead of me, but if they sign up and if they're interested, then it'd be interesting to see who these people are. The demographics of whether they're authors, publishers, or I don't know, librarians, or people with disabilities. That's the that'd be interesting. So
right. I mean, I hope that we can distill this information and then potentially put together groups that we can focus on helping. So, but
even this group, this half-day session, as credit to you guys, especially credit to Shamsi. No credit to you guys, I'm afraid. She's the one. She's the one who the particular day I think, but. The fact that we've got breakout rooms, that was all organized, before you had all this flood of people coming in. So it's already divided into 3 or 4 breakouts. That shows a lot of organization. And there we'll see which group gets more people interested. And I think this is not a. I think this is bigger than tech. This is not a tech thing. This is an accessibility thing. And I wouldn't be surprised if there are a lot of publishers. By the way, I've also sent out, send out email shot, put in LinkedIn, etc. And a few people have said this is interesting. These are publishers, big publishers. So they're interested. It's a big accessibility is a big thing. And finally, if arXiv can crack this, then it's cracked for everyone because you've got the most complex text. This is why it's so complex. You got 2 million, legacy documents, free for all tech, which is the most complex. So it's great to see what happens here. So all the pressure's on arXiv and on us, I think now.
We're looking forward to it. I'm afraid I have to jump